Hi, welcome back. The last time we looked at this one, I left off with the initial impression and first overview, getting it out of the cabinet. I did a power-up test without the tubes to check whether the Selenium rectifier was working. We found that it was. We got about 300 volts on it, and I'm not sure if that's too high, too low, because obviously there's no current being drawn here. And so the next stage was obviously checking the power supply. And what I did then was to go through the whole power supply section visually and testing it to check if there are any components burnt out or any shorts or anything of that sort. I'm just going to do a quick overview here with you so that you'll see exactly how I go about that before I power on with the valves in there. So if we look at the schematic, first section we have here, we have the power supply section here, and the first thing we should check for, and this is redundant because as I said we've actually done some checking, but the first thing we check here is for the power transformer. Testing the primary is a question of putting a multimeter across the two pins there, which will be neutral and live, or live and neutral. We don't have polarized power here. And checking for continuity across this primary when we flip the switch on the radio. So that's what I'm going to do now. Obviously I've checked things like the fuse, made sure that that is okay, because that's usually a problem. When you get nothing there, you find the fuse is blown. In this case it was not blown, but there was a very, very high value fuse in there. I think it was about 6 amps. So that's been changed. It's now at 0.315, I believe I have in there. Schematic calls for 0.3 amps. And I'll just show you how we do that check quickly, okay? So first things first, we take a multimeter in continuity and put it across the prongs here. And as you can see, we get open circuit, all right? So when I switch on the radio by clicking one of those buttons, there's my 61 ohms, which is about right for a primary of the power transformer. And that tells me that the power transformer primary is fine. So I can now go ahead and I can actually do my little painting trick here, which is telling me that that is done. Okay? Next step would be going on to the secondary. Now, I know from the previous experiment or the previous trial that this section is working. There's actual voltage coming on there, and there's actually a voltage on here. What we need to do now is to check from this point onwards, so from the positive of the Selenium rectifier onwards to all the points where the B plus goes, and check that we have what we expect to find at those points, meaning either a direct connection or certain resistance in the path depending on which position we're testing. So let's take that to the next step. So the first step is putting the multimeter one connection on the B plus, the output of the Selenium rectifier, and we follow the B plus line. It comes to the first capacitor. No resistance, should be no resistance. We don't even measure that if we find the next stage is okay. We follow that line up and it goes to the output transformer over there. It comes in the output transformer there. It goes through the primary of the output transformer and to pin 7 of the EL84 tube. So let's check that one. What we have here is 724 ohms, measuring from the output of the Selenium rectifier to pin 7 of the EL84. So it seems that continuity is there. I then take it one step further and I go to this point here, which is comes out of part of the output transformer acting as a choke and goes to the 1K resistor. Let's see what we get. this is the resistor in question. That's the 1K resistor. One side of it should be, no, it's not that one. That's the one there. So that choke has a DC resistance of 17 ohms. And that's when I meet the 1K resistor. The other side of the 1K resistor, I read 1037, which means this resistor is fine. It's probably 1.01, 101.02, which is well within spec. And I now check for the next stage, which will be, if I follow that line through that 1K resistor, it meets the second capacitor, and then it goes up to the screen grid of the EL84, which is pin 9. And there I should get the same resistance as I got on the other side of that 1K resistor. Let's have a look at that. Yep, I do. So the B plus is fine as regards the EL84. So we move on to the next tube. And the next tube, we've just checked that one, that's fine. That voltage there should be arriving, that one should be arriving. If we go a little bit further back and we come to this point here, that point there then carries on and we follow it to this point, which then goes through a 220K resistor, up there, up there, up there, another 220K resistor, another 4.7K resistor, pin 9 of the EABC 80. So what I should read is approximately 4.7K, 220 plus another 220, which is 440, 444, 440 plus 4.7, 444.7, plus that 1K, about 445. Let's see what we get. So we're looking for pin 9 of this tube, 470, we said 447, 448. It's within spec, so those resistors will seem to be fine. That means the B plus will arrive at that tube. Go back here. If you go back to this point here, we then go across here, and that's the next point. That point then goes up through a 2.2K, through that coil there, through that coil there, and it goes to pin 7 of the EF89. So what should I read there? I should read a series of resistances. I should read that resistance there, which should be very, very small. That one there should be very, very small. And 2.2K here. And going back, if you recall, we're measuring from this point. So I should be getting that 1K as well. So 3, 4K. Let's see what we get. And that was pin 7 of this guy that we're looking for. 3.2K. Brilliant. That means B plus would get there as well. And where are we now? We go back to the schematic. We've checked that one there. We've checked that offshoot. That doesn't go anywhere else in terms of DC. We've checked it to there. Come back down here. We've checked that one to there. No more DC. Where else is there DC voltages? Nothing on this end. It carries on through there. We carry on this side. What do we have? It goes through that resistor there, which is, I believe it's 1.5K. It's the writings on the other half of the copy. Goes through a coil there, a coil there. These are the output, the IF transformers. And it goes up to pin 6 of the ECH81. So pin 6 of the ECH81, we should get low resistance, about 1.5K, plus the original 1.5K, so about 2.5K. So let's remove this tube. And we're looking at pin 6 of that one. 2.5, brilliant, just about perfectly right. So that one is done as well. Now, where were we? We've done pin 6 of that one. Where else is there a B+? Let's go back to this point over here. So if we come over to here, we follow this line up and we have 39K over there. Comes up, 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 up to pin 1 of the EF89. So pin 1 we should get 39K plus the 1K. Let's see what it is we actually get. Pin 1. 40K, 40.6, which is spot on. So that one is fine as well. Back to the schematic. We've checked that offshoot. Now if we follow across here, what do we have? We have a switch. That switch would power either the, this would power either the FM section or the AM oscillator. So if we have the FM connected, we should see from that original point we're measuring, this comes up here and it goes to the FM block. Now I'm not opening the FM block, but outside the FM block there are 2 resistors. So I should measure to that point 1K, and then I should measure to the entrances or to the inputs of that FM block. There's a 33K and 8.2K. So let's have a look at that. There are those 2 resistors. So if we measure to the start, I'll presume that is the start. That's where the 2 are joined together. I get nothing. And why do I get nothing? Because my FM is not pressed in. Right. So let's feel on the front. Push FM in there. Did I get FM? No, I didn't. There's FM. There's our 1037 as we expected. And then we go to the other side of that resistor and we get 34 minus 1, that's supposed to be 33. Perfect. That one's right. And the other one, we get 9.2 minus 1 should be 8.2 or so. And that resistor reads 8.2. Perfect. So it seems that all these are fine, with the exception now of the final FM measurements. If we can actually measure inside the can, and what we should measure inside the can is if we take that resistor there, 33K that we measured, we've got it right there. If we follow that through, goes up here through that transformer, that coil, and it goes to pin 6. Okay, so we should have a measurement on pin 6. And then if we follow that one through there, goes up there, through that coil, and that goes up to pin 1. So we should get a reading on 1 and 6. Let's see what we do get. 1 and 6. Pin 1 is 9.2, which is that 8.2 plus 1, which is fine. And 6 is 34.3, which is that 33 plus 1, which is fine. So there we go. We've got all our DC voltages apparently working perfectly well. All these tubes seem to be receiving the right or have the right connections to the B+, to the various stages of B+. Meaning that when we switch it on with the tubes in, we should have B+ voltages arriving at these tubes. The resistances measure fine, which means that all the voltage dropping that happens along the way seems to be set to work properly. It doesn't mean that it'll be a clean B+, it doesn't mean the capacitors are fine, but at the moment it seems that we can actually switch this on and not have the thing go bang, all right? Which is exactly what we're going to do next, because I'm dying to know whether this thing is working at all, which would be really a bonus. I've said this before and I'll repeat myself. It really is a pleasure when you restore a radio that's already working partially, that is receiving your expected signals, preferably on all channels. That just means that when you do the restoration, you're improving along the way, which is easy because then you just, you go one step at a time, and everything you do, you check before and after to see that you've made an improvement. So let's set this up to power it on for the first time and see what we have. What I have at the moment is I have all the push buttons on the radio off, so the radio is effectively switched off. I have my dimmer reducer ready. I have it active. I have one lamp on only, and I'm going to put it on. So we have the full voltage, but through one lamp, which is the greatest reduction. I have my speaker connected. That's very, very important. You do not switch this on without a speaker. You can blow your output transformer. Putting this volume fairly low. I'm going to activate shortwave. The dial lamp came on and the dimmer lamp went bright and then dimmed. And it's going bright again as the tubes start conducting. So yeah, that's a good sign. That's exactly what we expected. Do I hear anything yet? Oh yeah, I hear some noise. Okay, good. I'm going to give it another lamp, so reduce the restriction. And I've got the right noises. I'll give it another lamp. So I'm drawing 200 milliamps. The voltage the radio is seeing is 218 volts. So it's almost at full power, or rather at full voltage. The way it's set there is 220 volts. And let's see. We have no antenna. So I'm going to put an antenna in here. Just the external long wire. Okay, we've got something. And that noise is from my Wi-Fi. This Wi-Fi router through the mains is a pain in the butt, but I've got a way to disconnect it here. There we go. No more Wi-Fi noise. So what do we have? Volume higher. Yes. We have shortwave.
You get to meet people living in China without actually coming face to face with them.
Visiter un camp de réfugiés, le chef de la diplomatie française a regretté.
That's brilliant. While we're here, I want to show you what the shortwave, they call it KW looper, which is the fine tuning does. What we have is we have this button, this knob here controls the AM tuning for the AM channels. This one does the FM tuning and moves that dial at the bottom. Now, when you have it on shortwave like I have now, I can tune with the normal AM tuner, and when I'm close to the channel I want, I can fine tune it with the FM dial. I'll show you. There's something there. I can go to the fine tuning. There we go. So it basically gives me a good band spread. Brilliant, that works. Okay, Let's try medium wave. I don't believe we're going to get medium wave because if you recall the Farad antenna fell off, but we'll see. No, just noise. Long wave will be the same, I presume. Now for the one that I consider most important, which is FM. Let's pray. Oh dear. Let me take off restriction because FM does need a bit more voltage. I've got the bypass on now on the lamp dimmer, and I don't hear anything. Damn. I don't hear anything because I'm dialing the AM tuner, idiot. Oh dear, still don't hear it. Let me try putting an antenna in here. That might help. There's something there. There's something there. This is on maximum volume. There's just barely something that you can hear there, but very, very little. So we have a problem with the FM. It's not as bad a problem as I had before because you do pick up something, barely, which isn't a bad sign. At least there's something. Let me try put the external antenna on here instead. Doesn't get any better. No, gets worse. Okay. But I do have something there, which is a good sign because it means that the oscillator part is working. So I've either got a problem with the tube. I don't have a restriction problem that like I've had before. There was a case where I didn't have the FM working. It was just a question of taking out the dimmer reduction. So I don't have that problem. I did try an antenna. I do get 2 positions on the dial, very, very dim, very, very dim. So my guess is either there's some capacitor problems in there where it connects to the main mixer preamp and the IF sections, or the IF sections have been twiddled. And I have not been able to check whether the IF transformers have been messed with, tampered with. So this could be just totally misaligned, but at least I'm getting something, which is a good sign. It's a good place to begin. Now let me test just the pickup input and see what we get. Now I've prepared the signal into the pickup input from the signal generator. I've got a 600 ohm, 600 hertz signal coming in. It's at 100 millivolts RMS, and I'm going to drop the volume, turn on pickup input, and we have our signal. Brilliant. Brilliant. Let's have a look at that on the scope and see what we have. The scope is connected across the speaker, so it's a 5 ohm, 6 ohm load in this case. That's pretty good. All right. I'm not going to take it to clipping or anything like that with the speaker on. I might do that later with a dummy load. so I don't create some havoc with the neighbors. But our amplifier is working, our pickup input is working. So in summary, we've got a few things right and a few things wrong. Our pickup input is working. Our long wave and medium wave, we don't really know. It's making the right noises, but we don't really know because the ferrite antenna is removed. Now it's supposed to work with the internal antenna as well, but because the ferrite antenna has been taken out, that may be required in circuit for the signal to get through. So we don't really know if that's a problem. I'll put that in and we'll find out soon enough. The long wave, medium wave, short wave, because it doesn't use the ferrite antenna at all, is actually working and is picking up. Not that sensitive or selective at the moment, it seems, but it's picking up, which is a good sign. The fine-tuning here, the band spread, works on that as well. The FM is the challenge. It is picking up on 2 positions on the dial. I presume, and actually I can confirm, that there are 2 pretty powerful stations fairly nearby. Funnily enough, one of them is being picked up here somewhere, which is at about 87, 88 on the dial. Oh, there is one at 88. Yeah, there is one at 88, and there's one at 89.5 or 89.3. So, yeah, we're probably getting those 2, but very, very softly. Which means that either the IF alignment's all gone, or the pickup section is buggered, or the tube is buggered. So that's a good start. It's a very good start. It's a relief, actually, because it means that I don't have to start from scratch. So the next stage that I'm going to do is I'm going to color in, like I did, or like I usually do, the parts that we've checked. I start painting it in. I go a little bit further than I did before I color in. I go a bit further than I did here. I actually go component to component and then paint it up. The ones I leave stay green, the ones I replace go blue, the ones I leave out go red. So I follow that code throughout the schematic, point by point, component by component. So the next stage I'm going to do is I'm going to finish the power supply, paint it in, make sure that everything is fine. Then I'm going to go to the pickup input, which is what we've just tested now, and I'm going to follow the signal through, and I'm going to check and correct any anomalies in the preamp, audio preamp. If you follow the signal here, you find this is where the audio signal comes in, and the signal comes in and gets sent off to the audio preamp. That triode in the EABC80 acts as an audio preamp, and then it follows and comes out through a load of tone control circuits into the power amp and out to the speaker. So I want to get the entire audio section, the AF section, completely colored and painted in, with every component checked. Everything that's required is changed. What I do now with the electrolytics, like that one there are a couple of electrolytics. There's one there. There's another one here. This seems to be non-polarized. That's to separate the tweeters from the main speaker. I check those for leakage and value and ESR. If there's leakage, I try and reform them with the capacitor reformer that I built. Something like this is a 15 or 20 volt capacitor. I use the power supply and check the current through there, reform them, try and get them to work as per new, and in that case I don't replace them, otherwise I replace them. So the next stage is to do all the AF section before I go back into the radio stages, into the IF and RF stages. All right, so that's it for now. Thanks for watching. See you soon.